So we have motion problems. Okay. Before we go into this problem, guys, I need to discuss the second law of Isaac Newton. Okay. In which this is very important in the acceleration, like that, velocity. Okay, so we should remember, guys, that there are three laws of Isaac Newton, right? In order we can understand this problem. Okay, number one, here like this. So the law of inertia. Okay. The second law is the law of acceleration. Okay, and the third law is the law of interaction or the free fall. Law of interaction or the free fall. Okay, like that. So it's gonna be like, so with this kind of problem, number 4, it's gonna be in the 2. So let's focus on the 2. So what is that? Okay, an object in motion will remain in motion unless acted by a net force. Okay, for example, if my net force is 0, okay, your car will not move or your object will not move because the net force is equal to 0. Meaning to say you have an equal magnitude or opposite magnitude, the other one is positive, the other one is negative. Your applied force and your fractional force or static fractional force will be equal. You add that one, you will obtain 0. Let's say I have applied force FA, okay, plus negative static fraction or fractional force is equals to 0. So this 0 is your F net. Okay, if this is 0, then your car, your object will not move. Okay, that's very clear. That's the first concept. Okay, the second concept will be, okay, if your net force is greater than 0, then your car will move or the object will move. So it takes a value of 1 above in order for your car to move. Okay? As long as there is a value. You get the point? You get the point? So F net will be always greater than your static fraction or your fractional force. Okay? Di ba mga palaga kang hitad? So F net must be larger enough in order any objects to move, and that is the second law of acceleration. And then your F net, guys, will be like this. Okay, maximum force net is equal to the mass times the acceleration, something like that. Okay, let's put acceleration as a small a because it will confuse us with the unit of current and electricity in the Ohm's law, which is the capital A, something like that, or sometimes small a. So, mag-agree na lang na ang ato acceleration here, small a, not to, not to collide, or not to clash, or not to confuse the unit of ampere in the electricity, okay, or electric current, something like that. You get the point? So this is our formula like this. Okay, now, what you observe here, what is the definition of acceleration theory? What is an acceleration? In our high school physics, what is our acceleration? Because it's just the same. The definition in your lower years is just the same in your definition in the college. The statements and theories will never be the same. That's why stock knowledge is important to pass certain examination. You get the point? It's not really how good you are in solving problems. It's the basic foundation that you accumulated in your brain cells that will make you pass in different types of examination, especially math and science. It's not English, social studies, psychology, politics, math and science. Okay? You get the point? Okay, that's gonna be like that. Okay, so acceleration by definition is the rate of change of velocity. Okay, the rate of change of velocity. So meaning to say this is mass times delta V over delta T, wherein this is your change in velocity, the delta V, and your times will be the change in time from point A to point B, and also velocity from point A to point B. Okay, and this is your F net, something like that. Okay, so you have now the equation like this. Okay, now How can we achieve another formula in this case by having this one? So you have to multiply the mass and the change of velocity, and in definition also this is momentum. Okay, momentum. The symbol is letter P. So I can say directly that this is F net force is equals to the change in momentum. Okay, or the momentum itself. Okay, it's gonna be P, right? Or delta P. But we still have delta T at the denominator. Okay? You get the point? So I could say here secretly, okay, momentum is equals to the mass and change in velocity. This is the definition. Okay? Like that. You have the momentum from the second law of acceleration you derive. Now, this equation also, we can create another equation. Okay, for this. So take note, if there is a denominator mga panangkakuhitan, you always try to multiply it to something. It's always, it can be eliminated somewhere along the way to simplify your equation. Just like this. Okay, you need to multiply this by delta t. So delta t, and the other one also is delta t. Now cancel the delta t. What's left? We have net force times delta t is equals to the momentum, right? So it's, if I will convert that to statement, I will say momentum is equal to the change of time, which is the delta t, okay, like that, times the net force. Okay, like that. So this is also another formula of momentum. We have now another formula. I have the momentum mass times change in velocity, and I have also the other version, which is the change in time times the net force. Right. Now, if we try to dig it out, this change in time and net force is also called an impulse. Okay, impulse. So you will say impulse or I is equals to delta t times F net. So this is your another equation you derive out of your second law of Isaac Newton. So you can still derive another too much equations in your brain cells, something like that. And then, like this. But honestly, there are also equations that are introduced in the book. You can make your own talaga siya, guys. As long as it is, you can validate that way as scientific laws, that it is logical and to be true and to be correct. Okay, something like that. Okay, we have the impulse here. Now, I can now have a definition of impulse. I will say, impulse is a change in momentum. Like that. Impulse is a change. I converted the formula into a statement in terms of words. Okay, so impulse is change in momentum. Okay, like that. Okay, momentum is the mass times the change in velocity. Okay, change in velocity, like that. Okay, and also momentum also, or this is the change in time times the net force. Okay, like that. Okay, and I have also acceleration is the rate of change of velocity. Okay, so through this I can create my own definition by understanding the formulas and equations only, not referring to the book or bookish, something like that. Okay, because in the books it presented in another terms, not this, not the same as this. As long as you can understand it, you can play around the terminology, the vocabulary, the spelling, the grammar, etc., so on. So if you really understand how to derive these problems, or assuming also that you are good also in English, okay, because not all also good in English. Okay, you get the point. Something like that. We have the impulse, momentum, and acceleration. Okay, this is the second law of acceleration. Now, we need to solve now this problem number 4 because I introduced already the theories. Okay, erase. Okay, nakalangga. So, this is our theory before starting to solve the problem. Oh, may ganun? Yes, may ganun. Okay, so a car begins driving from a stationary position. Okay, like that. Okay, so a car begins driving from a stationary position. It accelerates at 4 meters per second for 10 seconds. then travels at a velocity speed for another 10 seconds. Di ba? Makalibog. All in the same direction. Nakakaloka. How much distance has it covered since it started driving? Oh, di ba? Yung ano na, mixed analysis, right? Now, we need to draw and to sketch and to have a diagram so that we can understand properly. Okay, this is the car. This is June car. This is, shall I say, this is Toyota Camry, right? Like this is a, luxury car. Imagination. Luxury car of Junjun worth 2 million pesos. Imagine. Only I am driving here, right? I'm enjoying driving my car, my brand new car. Okay, like that. I am in a stationary point here at point A, like that. Okay. Now, what's that? It accelerates at 4 meters per second. Linear. Ganon. It accelerates up to point B. Let's say we have 4 meters per second. Okay. Like that. And then it covers a time of 10 seconds. Meaning to say, it obtained an acceleration of 4 meters per second that is due to 10 seconds time. Okay. Take a look how it is being phrased. The sentence, the comma, like that, because it's still part of the conditions, okay, of your problems, how to solve it. Okay? Okay, mga talaga ang hitad. Now, after that, is this a comma? Then travels at a steady state. After that, it travels at a steady state already. Steady state na siya. Okay, until 2 point C, steady state. So what do you understand about the steady state? Theory. Okay, steady state. What do you understand by this? Steady state. If we remember general chemistry lecture, what is a steady state, Sir Sotero? So steady state meaning it's in equilibrium, meaning to say the time is not relevant, meaning time is constant, meaning this is the period where the time no longer relevant in your chemical reaction, meaning to say you establish the state of dynamic equilibrium, meaning to say your concentrations are no longer changing. Okay? It stops reacting one over the other. Meaning to say, your chemical reaction has completely stopped. The same like this also if we apply our car. So this is the steady state only, meaning we did not consider the time already, independent with the steady state. So meaning to say, at constant speed. Okay, like that. At constant speed. Ganon. So from point B to point C, mga palangga, kung hitad. Okay. Now, how much distance has it covered since it started driving? Okay. So take note, how much distance has it covered since it started driving? Okay. So then he travels again another 10 seconds for a steady speed. Okay. Like this. Meaning to say, nag-steady siya sa iyang speed at 10 seconds. Meaning to say, the time no longer changing, it's always 10. You get the point? Because it's specified also here that it's 10 seconds having the steady state speed. Okay? Meaning to say, he obtained a speed constant by having the 10 seconds all throughout. Meaning, it doesn't reach to 9, it doesn't reach to 8, it doesn't reach to 12, 10 only. Meaning, it's just the same saying, no longer dependent with time, because it's the same all throughout, 10, 10, 10, 10. You get the point? Sobrang malalim ang pinaghuhugutan, di ba? Because if you will say, constant the time, you will never mention the time, actually, but that is literal to understand. Here, it's not the case. We have the time, independent siya sa time because the time is no longer changing. It's still 10 seconds. Okay, you got the point. That's why it's constant speed. Because the time doesn't change, always 10. Okay, like that. You got the point. Ganon. Here, nag-10 na siya. Okay, so 10 pa rin siya. Ganon. So another 10 seconds. So, see, gives you na sa 5, 10 seconds, and then 10 seconds also. Okay? So independent of time, right? Or steady state. Okay. How much distance is it covered since it started driving? So we're going to say the total distance from DAB here, when your car reaches here, with the Toyota Camry, your Toyota Camry is reaching here and driving here and enjoying something like that, okay? And then going to C, okay? And then my distance covered also from D to, let's say A, B, C, from DB to C. So we need to add this two portion, okay? Now, from the first half of your linear motion, because this is only linear motion, there's no curvature, there's no projectile, and there's no curvature, there's no parabola or hyperbola, something like that. Okay, you remember that one in trigonometry or whatever, analytic geometry, I think so. And then your second half from B and C is also linear. Okay? Alam nga mag-curvature siya, dinlupad na ang sakinan, something like that. You get the point. Okay, so here, mga palangga kung kita. Okay, we have the acceleration and we have the time. Okay, like that. Here is a steady state chuba chucho. Okay, now you can apply equations that is necessary to solve the equation. Okay, because we have now the data, right? Okay, so distance AB, how can you compute the distance AB here in this situation? Distance AB for this. Okay, how can you compute this equation? Okay, now, do you remember the equation I told you a while ago? Okay, like this. Diba? Ganon. So there's a lot of equation. Okay, so final velocity is equals to initial velocity plus AT. Vf squared is equals to Vo squared plus 2AD. Ganon. Distance is equals to 1/2 Vf plus Vo times T. Ganon. D is equals to Vot plus 1/2 Gt squared. Ganon. Okay, now instantaneous velocity is equals to xf minus xo over the time. Average velocity is equals to Vf plus Vo divided by 2, right? Because average velocity. Okay, ganon. So these are the equations to be used. Okay, so look at this equation. Okay, to solve for the distance. Okay, now, mga palangga kung hitan. Okay, now, check the equation which is applicable. For the first one, you have an acceleration and you have the time here. So, kani siya applicable. Okay, and then this also, equation 1 is applicable, equation 2 is applicable also. Okay, like that. And 3 also is applicable. Okay, like that. Now let's check for equation 1 first. Okay, you get the point mga palangga? Okay. And then we have also another distance is equals to the velocity times time. This is a constant speed. Okay, like that. Okay. This one. Okay, the AB ba yaw? The AB distance ba yaw? Distance, velocity times time. Okay. Now, how can we compute? So, use this equation 1. So, Vf, okay, you don't have the final velocity. Okay, but you have the zero initial velocity. Okay, 0 plus the acceleration of 4 meter per second squared. Okay, times 10 seconds. Okay, ganon. So cancel, cancel. So your Vf will be 40 meter per second. Okay, this is your Vf in going to A to B. We are still now in the first half. Okay, you get the point mga palangga akong hitan. Okay, now, here, constant acceleration na kadriaring higayon na. Charot. Okay, how can we solve by using the Vf already, in which we get that here, right? Okay, now, we have the Vf, and we have the Vo, and we have the distance, and we have the acceleration. Okay, you get the point. So our Vf now will be, okay, or let's go back to this also. We can use this, no problem. Okay, but we still use this one. So Vf, we have now the 40 raised to the power 2 is equal to the initial velocity, which is 0 squared, right? plus 2 times the acceleration. We don't have acceleration here because it's steady state, right? And then we have the distance here. Okay, like this. So this is your equation 2. So how can we solve the acceleration here? How can we solve the acceleration here? Okay. Find also another equation that involves the acceleration. Okay, this equation 1. Okay, equation 1 is Vf, which is 40, is equal to initial velocity 0 plus acceleration times t, right? Like that. Because t, you have t which is 10 seconds from point B to point C. Because you are now in the second half, right? So it's gonna be times 10. Okay, and then it's gonna be acceleration 40 divided by 10. So your acceleration here is 4 meter per second squared. Now you have now the 4 like that. Then substitute, go back to 2 again, so that you can solve for the distance with distance B to distance C. So we have 40 squared, 0 squared plus 2 times the acceleration, which is the 4, times the distance unknown. Okay, pila man siya. Okay. So, okay. So this is gonna be your, your distance. Okay. So 40 squared is equals to, okay, divided by 8. So we have 200 meters. Okay, we have now 200 meters in the part of point B to point D. Point B to point C. Because we break that. Okay, now in first half, what is our distance here? DAB, how can we compute that one? DAB. So we need to think that is a constant speed. So we will use this distance is equals to velocity times time. So it's very easy. So distance AB is equals to the velocity, which is the 40 meters per second, in which we can compute that here in this first part. So times 10, because it's 10 here, right? This is 400 meter. Okay. Now, the total distance will be, I told you a while ago, is DAB plus DBC. The DAB is 400 meters, then DBC is 200 meters, then bingo, we have a total distance of 600 meters. So, June covered a total distance of 600 meters from point A to point D by using his Camry Toyota luxury car. So the answer is 600 meters. I will check in my problems if 600 meters really. Yes, perfect. 600 meters. Okay, ganun siya. You need to break talaga siya, guys, ha? And then think what is applicable formula using the kinematics linear motion. Ganon. Okay? It's very easy to solve, right? Any question so far? Nothing? Sorry guys, wala mo nakita kong board. Uy, ganun. So, di ba? Muna siya yung mga computations. Ganon. Okay? Di ba? Okay, any question so far? Mga palangga. So this is linear only, ha? Kinematics linear that does not involve curvature, trajectory, or projectile. Okay, like that. Okay, now, mag-solve pa tagdagan o di na? Charot! Okay, so, yes, kalas. Only the problems for now. Because I still have to research more problems. Okay, like that. You get the point? I don't have books in physics and chemistry right now in my room. So in my room in the Philippines, I have a mini library. So it's there all my books. Okay, like that. Okay, it's in my room. I have a mini library in my room. Okay, you get the point, mga palangga. And every time I go vacation, I still need to scan it, read at it, something like that. And still, all my notes are still there. in high school and in college, including the review materials. Okay? And the chemical engineer's handbook is still there. Okay? The very thick one. Okay? And I plan to have a new project to intensify, to extend my mini library into a little bit bigger. I will put that in the second level of our house. So that every time we will do the vlogging, I will be going there and let's do the vlog, something new. I need to have my audience, mother, my nephew, my nieces, like that. And then I will be the one to discuss with them. Or I can continue my master's study, pursuing chemistry or physics, something like that, or environment. Then I could be able to become a professor someday in one of the reputable universities in the Philippines. And thank you so much, guys, for watching this. Again, I'm a singer, Eternal Voice, Sotero. If you like this video, you can comment down below in the comment section. And you can subscribe also on my YB channel if you like. And then you can also go to the bell notification, okay, like that. And then I'm very, very happy for that. This is again, I'm a singer, Eternal Voice, your YouTube content creator, your social media influencer, Science World. Bye-bye. God bless everybody. Nakakaloka. Nakakaloka dyan dyan. Okay, wala siya guys. Diba? Charot. Hello! Nahuman ako vlog, uy.